Good evening, everybody. It's Dana. I hope we had a lovely weekend. Today we're going to talk physics. You're all welcome to this lesson. Alright, we have already established some facts on the concept of motion and their changes as they occur in different particles in our previous lectures. Another dimension to this is to analyze these motions as well as their causes. Now, how can we achieve this? This then leads us to the definition of what we have for today, dynamics. Okay. What is dynamics? Well, dynamics is simply the motion of particles, putting into consideration the causes of such motions. But to adequately understand the effect of any force on an object, we will have to explore the three basic laws of motion as explained by one of the greatest scientists of all time, Sir Isaac Newton. Newton's first law of motion, which is popularly known as the law of inertia. Okay. This law states that a body continues in its state of rest or in a constant uniform motion in a straight line unless it is compelled to change its state by an external force. But why is this law called the law of inertia? In fact, what does inertia mean? Well, inertia is the tendency of an object to remain at rest, if at rest, or to keep moving, if in motion. And this law is called the law of inertia since it expresses the tendency of bodies to remain in its state of rest or uniform motion. Now, we need to understand all of these concepts so that when we come across problems, we can easily solve them with little or no stress. So you need to understand them very well, okay? Do you know that a bottle placed on a table will continue to remain on that table forever unless there is an external force, such as, say, a push or a pull, acts on it? Do you also know that a football played at a point by a footballer will tend to continue to roll in a straight line unless a force acts on it to either make it stop or change its direction? This law of motion is actually an interesting concept that I don't think any of us want to have issues with because it's very easy and straight to the point. Now, mass is a measure of the inertia of a body. For example, you have a truck and a kid's bicycle. Now, a truck will have more tendency to keep moving than a child's bicycle, right? This means that the larger the mass of an object, the greater is the inertia. Now, this is fair enough. But most times, mass and weight are used interchangeably in a wrong manner. This is so because both of them are two different concepts. But we shall talk about them much later, okay? Now, Newton's second law, I've mentioned Newton's first law already, which is also known as the law of inertia. Newton's second law of motion states that the applied force, F, is directly proportional to the rate of change of momentum, and this takes place in the direction in which the force acts. So Newton's second law of motion is indicated, written mathematically, as this is the force F, which is equal to the change in momentum over time. I'm sure most of us are familiar with this, but there is more to this than that meets the eye. Now, momentum is defined as the product of mass and velocity of a body. So momentum is symbolically written as P, which is equal to the mass of the body times its velocity. This is how you show momentum mathematically. So if we rewrite this, say, suppose a force acts on a body of mass m. Let's take that down now. Mass m for a particular time t, and it causes it to change its velocity from u to v. U is always the initial velocity of a body. U is always the initial velocity. V is the final velocity, always. Now, suppose we have this scenario. We can rewrite this Newton's second law as very easy. Physics is just connecting the dots, and that's all. Put one formula into another formula, you've gotten it. So we can rewrite this Newton's second law as F. Remember, we said it was the change in momentum over time. Now, change in momentum, body moves from one velocity to another velocity. So we have this as mv minus mu. Remember, I said in our previous lessons that if you want to get a change of something, it's always the final minus the initial. Okay, so just take note of that over our time t. So if we go ahead, we get m bracket v minus u. You know, if you open up the bracket, you get this stuff back, right? So over t. So you can see that Newton's second law has been reduced to this mathematically. But if you check something, I hope you all can see my screen. So if you check, now you're going to see that this stuff here is like an equation that we're already familiar with, right? Now this is simply acceleration. Remember, acceleration is change in velocity with time. So this is simply acceleration, v u over t. Now what happens here? We can get another relation from this Newton's second law. And if we put this back, we end up getting this force is directly proportional to acceleration. And we've gotten this relation. I know most of you know this relation very well. Very, very well. So we can see that Newton's second law has been restated as this. Now this equation, which most of us used to solve a lot, is a fundamental equation of dynamics and is one of the most important equations of physics. Newton's second law had some cool deductions. I'm going to show you what I mean by these deductions. If you know in physics, if you don't get the basics, you end up missing it. You end up confusing yourself. So Newton's second law had some deductions. All right, guys. Now remember we said, let me rewrite that for us to see. You know, F equals the change in momentum mv minus mu. Hope we are all together. So remember we said F equals change in momentum over time, right? And if you cross multiply, if you notice, you cross multiply, you're going to get Ft equals mv minus mu, right? So this is how most of all these formulas are gotten. Okay, so now if you notice the Ft here, the quantity Ft, this is called impulse I. Now this impulse I is the impulse of the force. So we can say I equal Ft, right, equal the change in momentum. Hope you guys are taking this down. Very important. We're going to start solving questions very soon, and you're going to see how all of this apply. Okay, now this impulse is the product of a large force and a very short time during which this force acts. Okay, so you can just say that impulse is the product of force times time, as we have seen here. Now you see how all of this relates. We're beginning to connect the dots gradually, little by little. So sometimes you may be asked in a question to find the impulse, and hearing this, you may be thrown off by that, we're not taught this, so we're only giving the equation for Newton's second law. But you can see that from Newton's second law, you've been able to get impulse, right? So now, the unit of impulse is given in, that's the unit, is given in Newton second. Okay, now Newton's second law of motion is very important, guys, and useful because it allows physicists like you guys and me to study the forces of nature through motion. Now, if we know the forces acting on a body, we can determine its motion, right? And on the other hand, if we know the motion, we can deduce the forces acting on the body, right? So let's see an example. Let's just take a very short and simple example. Rush, you're with me, right?
Yes.
All right, good, beautiful. Now let's take this example. A block of 20 kg mass is pulled horizontally by a force of 10 Newton along a frictionless floor. Now the question says, what is the acceleration A of this body? Now let me give you a little trick, okay? In physics, so you don't even need to start looking for where to begin. Just simply put down the parameters that you were given. While I was in school, that was what we were told, and it really helped me in all my exams, and it made my work look very beautiful. So first of all, this is our solution here. So you put down solution, and you take down the parameters. What were we given here? The block of 20 kg. I'll take that down on our behalf, okay? Because of time, I can't write down the questions for us to see, so just follow me closely. So now the block has a mass of 20 kg. And it's pulled horizontally by a force of 10 newtons. So the force acting on the block is 10 newtons, right guys? Now, this is along a frictionless floor. Friction does not act on this. I'm going to get there shortly. Now, what is the acceleration of the block? This is very easy. Once you know the formula, you can just impute your values, and that's all. So we know using our Newton's second law, which is F equal ma, right? If you put in your values, you're going to get your answer straight on. So the mass is 20. Okay, our force was given as 10. Okay, so our force given to us is 10 newtons, right? 20 mass times the acceleration A. So if we do this, we get 10 equal 20A. So when you divide both sides, you're going to get A as 0.5 meter per second square. Let me explain something before we go on to solving more questions, alright? Now let's consider the forces involved in walking. A person begins walking by pushing his foot against the ground. This is the action. Take note of this. I'm trying to get somewhere. Now the ground then exerts an equal but opposite force on the person. And it is this force on the person that makes the person move forward. Now let me take another instance. I'm heading somewhere. Let's consider two friends, A and B, having a fight between them. If A slaps B, what do you think will happen? To me, it is obvious. B will slap A back, you understand? So B will tend to react based on the effect of that slap, especially if the slap is very hot. I swear that if you slap me or slap, I'll slap you back. You know, that kind of thing. Now, Newton's third law explains this. So we can state Newton's third law as to every action, there is an equal and opposite reaction. So in summary, Newton's third law is a law that involves an action in which one body exerts a force on a second body. Now the second body always exerts a force equal in magnitude but opposite in direction on the first body. See how interesting this can be, right guys? So consequently, it is impossible to have a single force that is separated, for forces always occur in pairs, since each of them cannot exist independently without the other. Now we need to make this explanation straight on so that we can understand when questions are given to us. We need to understand the concepts first before trying to attempt to solve the question. Once you understand the concept, any question will be a piece of cake. Okay? So now, this is why if a gun is fired, the forward movement of the bullet when the trigger is engaged provides the action force. Try and imagine this. Thus, the person firing the gun experiences a backward movement. And so, a person that is firing a very high-speed gun must be balanced with his weight, well adjusted, okay, in order not to be flung to the ground after firing. I think most of us that watch American action movies, As you fire a gun, you receive like a backward movement. This is just what Newton's third law has explained. Physics is a natural science that helps us to understand the behavior of the universe, and that's just it. No big grammar. Now, with the knowledge of physics, we see that we've been able to describe what most people experience, but cannot explain why such happens. So now, these three Newton's laws that I've mentioned are usually applied in solving dynamic problems. Now, when you're calculating for the acceleration of an object, guys, take note of this. It should be with your notepad to jot some things down. So when you're calculating for the acceleration of an object using the second law, for instance, which I said is the change in momentum with time, right? It is important to correctly determine the total force acting on that object. But how is this done? Hope I'm not too fast, guys. All right, I'll take that as a yes. So now, in order to do this effectively, we need to make use of what is called a free body diagram. Don't worry, we're going to take lots of questions today. So we need to make use of this, and this helps us to accurately solve questions in physics. And it even gives you more mark. If for exam purposes, you ask the question and you draw your free body diagram, forget it. You're in that course. That's just the truth, that particular question. So now, what is a free body diagram? A free body diagram is a diagram that represents the object and all the forces acting on it. Take note of that. But don't worry, it's quite easy to construct, okay? And also easy to make use of. Now note that the only forces that appear in the diagram are those forces that act on the object, while the forces that the object itself exerts on the environment are not included. Okay, guys, so take note of this. All right, so now let's take some examples to explain everything that I've said. Now, we have a question like this. An object with mass, you guys should follow me closely, okay? An object with mass 800 kilogram is lifted up vertically by a force of 10,000 newtons. Now, we're given G, which we know is a constant for acceleration due to gravity, as 10 meters per second square. We all know this, right? Now, they were asked to calculate the upward acceleration of the particle. I think this is easy, don't you think? Let's do this together. Now, first of all, like I said before, you list out your parameters that was given. So when you do this, what was given to us? Mass, M, of the object, 800 kilogram. And a force, F, of 10,000 newtons. So we have G as usual, which is 10 meters per second square. Okay, we are asked to calculate upward acceleration. Take note of this, guys. Upward, A equal this question mark. We don't know that. Now, like I said, to solve accelerations using Newton's laws of motion, okay, we have to use our free body diagram to make our work easy. We need to get the resultant forces, that's all the forces that is acting on that object at that particular time. So how do we do this? Now let's draw our free body diagram. We're going to use a block like this to represent the free body diagram, okay? So usually this is how they represent it. Just draw a slab, then use arrows to represent the forces. Now we said this, the question said that the object is lifted up vertically by a force. So this is indicating the force F, which is 10,000 Newton. Now, and definitely, like I explained with Newton's third law of motion, there will always be an equal or opposite force acting, right? So now in this case, the opposite force, all right, is the weight of this object, and the weight always acts downwards towards the center of the earth. You have weight, everybody has weight, okay? So this is W here, which is your weight. All right. Now, since we've done this, we need to get the total force that is acting on the object. So we say our resultant force becomes F Since W, which is the weight, is acting in the opposite direction, it is definitely going to be minus W, okay? Remember I said the forces are equal and opposite. So if you take F, W to this other side, F minus W, you have this equal 0. And so this is the resultant force for this question. Resultant force F minus W equal our formula MA. Remember this, guys, F equal MA. Don't get lost though. This F here now, in this case, is representing the resultant force. Now, since we've gotten our relation, all we need to do now is to put in our value. But note, though we've not talked about weight, but we're going to do that, okay? W is the product of mass of a body times the acceleration due to gravity, G. I know most of us already know this relation, right, guys? We're familiar with this equation, W equals mg. So in this case, we are going to put it here in our formula. So we have F, still using Newton's second law of motion, minus mg equal ma. So you see how we went from understanding the question to trying to solve it, right? So our F, what did they give us as F? 10,000 newtons. Hope you guys are following. So we're giving 10,000 newtons as the F. Let's put that into this equation. So we have 10,000 minus the mass was given to us as 800 times 10, which is a constant acceleration due to gravity, equal the mass again, 800 times our acceleration, which we are asked to find. So if you solve this, bring out your calculators, guys, solve this with me. If you solve this, you're going to get 2,000. You're going to get 2,000 equal 800A. So when you divide both sides, you get A to be, divide both sides by 800, you get A to be 2.5 meter per second square. And that is that. See how straight to the point it was. You just used your free body diagram to show the forces acting on the object, and voila, you have gotten your answer. So let's take another question. We're working with time. So let's see another question. Now, a block of 20 kg mass is pulled with a force of 10 newtons. This is just what happens around you. We're just asked to give it a numerical value, so don't get confused. Now, a block of 20 kg mass is pulled with a force of 10 newtons at an angle of 30 degrees with the horizontal. Again, find the acceleration of the block. First thing that comes to mind, I try to imagine the whole scenario first of all, okay? So I could actually put it on paper. So now let's say we have our block. This is our block. And they said it is pulled with a force at an angle of 30 degrees with the horizontal. So this is horizontal, the horizontal plane. Let's put it like that. Angle at an angle 30 degrees. Let's just say being put in this direction. So this is the force. This is the angle it makes with the horizontal plane, which they gave us to be 30 degrees. You can see that we are representing our question already to make it easier for us to solve. Now, the parameters given to us was mass, which is 20 kg, right, guys? Then the force, F, given was 10 newton. The angle theta is 30 degrees. Now, how do we solve this? Okay, we have to find the acceleration, which we do not know. Okay, right, so let's get to that. So our resultant force now becomes F cos theta in this case, because it has been said in the question that it's inclined to the horizontal. If it was inclined to the vertical, it would be F sin theta. Okay, so now this becomes F cos theta, still maintaining the equation MA, we're still using Newton's second law to solve all of these questions. You see why I made emphasis on Newton's second law. Now, we know our parameters, right? Our force given to us is 10. So all you need to do is just put in your values and you get your answer. Easy. Don't stress yourself. 10 times cos 30 degree equal our mass 20 kilogram times acceleration, which we do not know, right? So A. Now, if you solve this, I don't know if someone is solving along with me. Oh, guys should solve too, so I tell me if it's correct too. Okay. So if you do this, 10 cos theta equals 20A. Acceleration A, final answer is going to give you 0.433. I need somebody to solve this to tell me, but we'll move on as you're solving, okay? So this is what you get as your acceleration. Just punch in your calculators, you're going to get 0.433 meter per second square. And that is it. You've gotten your acceleration, and you've gotten your mark. Okay, let's take another question. All right. Who is with me on this one? I feel excited already. Okay. This question says, a body again of mass 4 kg undergoes a constant horizontal acceleration of 3 meters per second square. At least this time we're giving our acceleration. So let me read out the question first before we take down our parameters. So now the body of mass 4 kg undergoes a constant horizontal acceleration of 3 meters per second square. Calculate the resultant horizontal force acting on the body. First question. Now second question is, what will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second? Now let's take down our parameters. This question should be question 4. Let me start numbering them so I don't miss them. Okay, now the first parameter given to us is the horizontal acceleration, which is A, giving us 3 meters per second square, right? And the mass of the body given was 4 kg. Now we're asked to find the resultant horizontal force. To me, I feel this is easy. By now, someone should have gotten the answer already. Okay, we'll still do it together. So using the same formula which we know, F equal ma. If you put in your answer here, you get your resultant force gradually and you walk away. 4 times 3, which is 12 newtons. Remember the units. Always include your units, guys. Always. It's very essential. You can miss a mark because of it. So you've gotten that one separately for the first question. Now the second question is, what will be the resultant force on the body when it moves with a uniform velocity, constant velocity of 6 meters per second? I don't know if anybody's already guessing the answer. Well, they said uniform velocity. See why you need to understand your questions first. Now, this means that the body is not accelerating. This means that in the second part of this question, A is equal 0. The body is not moving. Remember I said acceleration is simply gaining speed, change in velocity. But the velocity now is constant. It's better we understand this very well than I rush through it, right? So, since it is constant, the acceleration is constant, what do you think will happen to the resultant force of the body? If you put in your acceleration 0 here, you're going to get your force to be 0. So the simple answer to that question is the resultant force on the body is 0. Okay, let me put it down. So the resultant force for the second part of the question, resultant force F equal 0. And that is it. So I'm going to give this as a take-home work for us to do. We've solved at least few questions. So you can just do this at your own leisure time. You need to keep solving more questions so you'll be familiar with them. No matter the way they twist the question in your exam, you won't even have any issue. Okay? Because you definitely see this kind of question in your exam. Now, you can take down, okay? Let F be the force of the engine. The resultant force acting on the car is F. Let me put that down. Take home exercise. Okay, so the resultant force here, F equal, let me just put it like F minus 800. So this is the resultant force. Let me put it like this. Now, they said, what is the force? That's this force F here. What is this force? Use Newton's second law of equation. I don't know if you took that down. I don't know if you got that. Rush, did you get that?
Yes.
I think the question is not even complete. Let me take it again.
Yes.
Let me take it again because we're only given the resultant force. So we have to find the force. We need other parameters, right? So find the resultant force if acceleration A is 6 meters per second square and if the mass is 500 kilograms. I think this is better now, right? You can solve this now, right? So find this force here, find the resultant force here using Newton's second law. Let me give you small expo using this F equals ma. I think you can do that. If you can't, you can ask me questions on the platform, okay? But we're going to move ahead. I want to solve one more question before we call it a 9. Alright? You can have a review of all of these questions at your own time. So let's take this one question. A body of mass 6 kg moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? So I like all this kind of question here. Okay, now the question said the body, remember I always say list out your parameters. So this is our question 5. So parameter given is m, which is the 6 kg. The speed v is 20 meters, which the body is moving with. Now they said it was suddenly hit by another body moving in the same direction, changing the speed of the former body to 50 meters per second. Okay, sorry, this is u. This is the initial speed. Let me take that down before some of you get it twisted. So this is u. Then the v, which is 50 meters per second. Alright, now let's solve. Okay, what are we asked to find? The impulse received by the first body. Remember at the beginning of the class, I don't know if you were there, Rush, but I'm still going to give it again. From Newton's second law, we're able to get the formula for impulse. We're able to get a relation for impulse. So we said impulse is also equal to Ft, which is also equal to change in momentum. So I wrote this down at the beginning of the class. So now, we're not giving force, we're not giving time, so that one does not concern us. So we'll just take the second part of it, which therefore impulse is equal to change in momentum. So that's how you put it. If you open this up, you have I equal m, this change means mv minus u. Are you following? Okay, so to get our impulse, we have impulse I equal the mass given to us is, let's look at that again, is 6 kg. So we just put that down, 6. Now the velocity, final velocity is 50 minus the initial velocity, which is 20 meters. Okay, so if you solve this, this is 6 times 30, right? And the final answer is 180 Newton seconds, which is the unit for impulse. So we've been able to get this answer easily. All right. So before we close, let me just throw a little light on what I said at the beginning of the class. Now, during this lesson, I mentioned that mass and weight are often used interchangeably in a wrong manner. Okay, I'm going to explain why that happens. Now, let us see for ourselves from both definitions. The mass m of a body is a property of the body that determines the body's acceleration under the influence of a given force. It is the amount of substance that makes up an object. Now, a body at the Earth's surface is subjected to the gravitational pull of the Earth. This force of the gravitational pull is called the weight. Okay? This force is called the weight. This is where I explain weight. Weight, W, weight of the body. Now, and for such a body released in space near the surface of the Earth, it has a nearly constant acceleration, g, that is directed downwards. And so the force of gravitational attraction on a body of mass m, which we refer to as the weight W, becomes W, which is the weight, equal mg. So that is how this formula came about. Now, this is the relation between, between mass and weight. This is the relation between mass and weight. The weight is a vector quantity. Let me be putting that down. So the weight, W, is a vector quantity. Okay? While the mass, M, the weight is a vector quantity and is always directed downwards towards the center of the Earth. But mass is a scalar quantity. Therefore, the unit of force, we know that the unit of force is Newton, right? Good. And that is also the unit for weight. Now, from experiments, it has been found that acceleration due to gravity, g, has the same value for all objects at the same location. And so if we take the ratio of the weight of two objects, we are simply comparing the ratio of their masses. And so in addition, acceleration due to gravity, g, also varies from point to point on the Earth. And it therefore follows that the weight of a body whose mass is m is different in different localities. And finally, the mass of a body is a natural property which does not change, but the weight depends on its location relative to the center of the Earth. And that is that for the confusion between mass and weight. So please do not use mass in place of weight, okay? I've been able to show or say the difference between the both of them, right? One is more like a force, the other is just a scalar quantity, which is actually the quantity of substance of a particular body or of an object. So with that, today's lesson, we've been able to solve questions on Newton's laws of motion, and we've been able to see how they have helped us to explain the motion of objects to an extent and how important they are that we know them. We're going to solve more problems on this, but for now, on your own, at your own leisure time, I urge you to try and take as many questions as you can on this, because the questions may vary. And if you have any questions, you can come to the platform and drop them. I hope one way or the other we gained something from today's lesson. So in our subsequent lessons, we're going to do more. We're going to explain as much as we can explain to you guys. Physics is a very interesting course that you don't need to fear. So you can drop your questions for me on the platform, okay? Always invite your friends. www.awoko.ng. Do not forget, Awoko. They help make learning easy for you, okay? So with this, we have come to the end of this lesson. Probably in our next lesson, which is tomorrow by 8 p.m, we are going to solve more questions before we move over to what we are going to have for tomorrow. So stay glued and stay connected so that wisdom will follow you. Okay, so see you in the next lesson. Bye, guys.